I remember when I was 3 years old, my family having to sandbag around our house in Scottsdale. So I've always been fascinated with water, too much water, not enough water, which is kind of the nature of what we deal with here in Arizona. So I'm happy to talk about those kinds of things. And I'll give you an overview of what's going on across the state, kind of zooming in. If you'd like, you'll see some maps that allow you to zoom in and see what may be going on in your county, and kind of how we keep those numbers together, how we look about things, because it's a little bit different than seeing all of those numbers, right? We have weather stations all across the state. We have weather stations all across the Southwest, but making sense of those numbers can be challenging. So we're not just going to look at one number. We're going to look at a lot of numbers coming together. And so as the state climatologist, that's kind of the perspective that I try and bring. We can zoom in and we can see what may have happened on a date, or we can kind of zoom out and look at what maybe is going on across a month or the last 6 months or the last few years, just to kind of see what those trends happen to be. So that's what we're looking at first when we're looking at the temperatures for the summer. So as a climatologist, as a meteorologist, we look at not just the summer that we're all used to. We look at what's called a meteorological summer. So we start counting from June, July, and August, and then boom, we end. We call that the meteorological summer. And so that's what you're looking at here. And we're not just looking at the state of Arizona, but we're zooming out and you can see the Southwest. And you can see that looking at temperatures. So those colors that you're looking at when we're seeing those more orange colors, those are adding up all of those temperatures from June, July, and August, adding them all together and comparing them to previous June, July, and August. Is this above or below kind of the temperatures that we're used to? So looking at the summer, June, July, and August all coming together, you can see for the Southwest, it was very hot. It was the 8th hottest on record. Also, to understand how we look at those numbers and provide that context, we have records that go back 130 years. So it kind of gives you that scale as to what we're looking at. Now, for Arizona, you can look and you can see that Arizona is all orange and dark oranges in our state for June, July, and August. And if you were to look at the individual months, so we can look at June, it was the 17th hottest. You look at July, it was the 24th hottest. And then you look for August, the 2nd hottest August on record, again, going back 130 years of record. So you can see that this was an exceptionally warm summer for us, and overall for the state of Arizona. So we look at things for the state, we zoom in, we look at county numbers, kind of rankings to see where we're at. And you can see that Arizona had the 3rd hottest meteorological summer, so June, July, and August. So it's been fairly warm those 3 months that we bring together and compare as our meteorological summer. And then looking at precipitation. So there are a lot of different ways to keep track of that precipitation, right? So we know that the monsoon season kind of starts June 15th, goes all the way till the end of September. But looking at that meteorological summer, so June, July, and August, so what happened during those 3 months, and kind of keeping track of that precipitation, doing the same kind of thing with that precipitation that we just showed you with temperatures. And you can see for the Southwest, right up in the center, so you're going into Arizona, you pop up into Nevada, and you've got Utah and a little bit of Colorado, a little bit of New Mexico on the west side of those states, and you can see that it's been fairly dry compared to normal amounts of precipitation. By the way, when I say normal amounts of precipitation, that's a climatological average that we use. So that means I'm looking at and comparing to those numbers, like how does it compare to other time frames. And so when we're looking at summer, so June, July, and August, looking at precipitation, and you see all those browns on the map, that's showing that it's been fairly dry for the state, across most of the state. So the Southwest, the 31st driest, again, out of 130 years. Where does that land? And then you zoom into Arizona, and you can see that Arizona June, July, August is the 12th driest on record. Now, if we zoom in and we look at the individual months, so you can see up there in June, this June we just experienced in 2025, we've got the colors up there on the map that show it was the 20th wettest June. I don't know if you remember the first week of June, we had a tropical system come in and it was wet everywhere, boom. We got a lot of precipitation. June is statistically the driest month of the year for the state. So getting a little bit of precipitation in June is unusual. And so if we get a little bit in June, it's going to look like we are ranking higher, and we are, but we're not getting an exceptional amount, a total amount of precipitation, because it's comparing what we would normally get in June. So June being very dry, we actually had a wet June, and so you can see that's where the 20th wettest landed. And then July and August is when we kind of expect to see that monsoonal activity. We'll talk about the monsoon a little bit here, but we didn't really get a lot of that activity. A lot of that monsoonal flow kind of stayed over on the east side of New Mexico, didn't really come into Arizona as much as we wanted for July and for August. And so you can see that July is the 14th driest, August the 16th driest, landing June, July, August as the 12th driest. So very, very good looking at those numbers. And then let's just for fun look at what's been going on for the last 12 months for the state. And so we're zooming in, you can see the maps again. We're looking at all of the weather stations all across the state, measuring the temperature for all of those months and adding it all together and then comparing it to the previous 12-month time frames. And so we're looking at September to August, and it's been fairly warm when we're looking at that. And if you remember last September, last October, last December, those were really hot times of the year. So last September, we were breaking records. We had 117 degrees for the first time in the Phoenix, at the Phoenix weather station. And then in October, exceptionally hot. We had 113 degrees at the Phoenix weather station for the first time. So kind of looking at those across the state, but if you zoom in and you can see the various different places across the state, so the different counties, you can see exceptionally warm kinds of conditions. November last year was starting to kind of act like a November, and so it started to cool off, and that was okay. December was not. And then we popped back into January, and January was kind of feeling like a January, where it was trying to cool off. But then we go February, March, April, May, June, July, August, all warmer than normal. And so overall, looking at that, especially ending up here with August as the second hottest August on record, you can see the ranking as the last 12 months, the third hottest on record for the state. So it's been warm. And then has it been wet? No, it has not been wet. So, you know, we can look at what happened last monsoon. It was very, very dry. We had, if we go back even, we're going to look at winter precipitation, but last winter in 2024, it was kind of average, so statewide. And then we had another dry monsoon last year. And then here we are coming out of that monsoon. So you're looking at September, October, November, December, and so on. You can look at the precipitation. And looking at the times, those May and June, when we actually had wetter times of the year. April, May, and June, that's the three statistically driest for the state. So we start to dry out in April, May, and then June, as I mentioned, is statistically the driest month of the year for the state. And those were the only times looking at the last 12 months when it was above average precipitation. Every other month was below average precipitation. And when you're looking at the location across the state, you can see kind of down there, Cochise County, Pima County, Pinal County, Santa Cruz. You're going over there in Graham and Greenlee. You're looking at Gila, all very dry. We did have a little bit of precipitation in Yuma County, and so that's why Yuma doesn't look as bad. Coconino County, not as bad, but you can see that overall, very, very dry across the state. And then this is what we're looking at. We report to the state every year looking at what's called the water year. So the water year is probably a new term for most folks. We count precipitation, we count the water from October 1st through September 30th, not just in the state, but we do that for the United States. Canada does this as well. So it's a way to keep track of the precipitation. It's kind of like a surplus. We get the winter, October, November, December, January, February, the surplus side of things. And then here comes summer, the deficit side of things. So that's where that water year comes from, October 1st through September 30th. And so that's what you're looking at here. It's a way for us to count our precipitation, kind of compare how we've been doing. So we are through the end of August. We're ending up with the 11th month for the water year. So starting with October 1st, we landed through the August. That's what we're looking at up here. And you can see that it's been very, very dry for the water year to date. So through August, we're not counting September when we're looking at this. I will be counting September starting this week as we get those numbers coming in as we finish September. But you can see going to August, it's been across the state very dry. And what you're looking at with that map, and it has those numbers that are in brown, those are looking at individual weather stations. So we're looking at the rain gauges, and those are ranking that same time frame. So we're looking at October through August, looking at that ranking compared to the period of record for those weather stations. And most of these locations, especially in the southeast, you're seeing those weather stations are in their top 5 driest for the water year to date. And you can see where we land for the water year to date. What's going to happen with September? It's probably going to end up being an average September to maybe a slightly wetter September, depending upon what those numbers are, how they come in. We'll have to take a look. So it's still not going to be enough to kind of take us out of a very deficit kind of approach for this water year. So we'll see what those numbers end up being, but it's been a fairly dry water year to date. And you can kind of see some of those records, kind of the long term. So going back the 130 years, on average, the October to August, a little bit of about 11 inches, a little bit more than that. The reason why I pull out there, so it says 1994 to 2025, I keep track of that separately so you can kind of compare what's been going on. 1994 is when I have us start the long-term drought that Arizona has been experiencing for over 30 years. So you'll see some of those kinds of things as well. And we'll take a look at that. So then we'll take a look at these kind of short-term droughts, and we'll compare it to what we keep track of with our long-term drought. The short-term drought is built by the Drought Monitor, and it's published every week. So I would encourage folks to take a look at this. It kind of takes into account where we stand with our precipitation. And what we're looking at on this map is kind of comparing the time frame. So this is, I think, last week's data. Going through September 16th is what we're looking at for that big orange and red map that we're seeing. But we're also looking at that same time frame the previous years. So what was it like in 2024, that same time frame? What was it like in 2023, that same time frame? You all may remember the winter of 2023. It was one of the wettest winters. We had to release in our reservoirs, so you saw water flowing, and there was a lot of precipitation from a very wet winter in 2023. Then we had a dry monsoon. So kind of keeping this, how it goes back and forth, it does kind of do that, but some are more exceptional than others. So you're looking here at the 2023, we're looking at the map that says September 19th, and that's showing us what we've been dealing with a very wet winter in 2023, and then a dry monsoon. And you can see that some of those oranges and those browns start to build out. The yellows and the white colors right in through there, those are abnormally dry or areas that don't have that short-term drought. So that's kind of a way to kind of keep track of things. You can see that the southeast, so Cochise County and Pima County and Santa Cruz are definitely dealing with those red colors 2 years ago. And that kind of has been persistent in the southeast. So coming through last year, September 2024, again, we had that same kind of thing. It wasn't a very exceptionally wet winter, but it was a slightly above average. And so that's a good thing. It moderates, you can kind of help the vegetation. But then the monsoon last year was very, very dry. And then as we moved into September and October, exceptionally hot, breaking records. And so then kind of backing up, this last fall that we've had, this last winter we've had, very, very dry. This monsoon, for the most part up to this date, very dry. And so you're seeing that kind of build out, that dry monsoon causing the degradation of our short-term drought across the state. Now, this is a different way of looking at that data, and this is when we're looking at, are we still in drought for the state? These kinds of things are how we evaluate and look at what's been going on. And so what my office does is look at the long-term drought for Arizona. And the way we do that is we look at not just lack of precipitation, but we also look at hotter temperatures, because hotter temperatures make a thirsty atmosphere and they'll dry out the soil. And so we look at what's called the SPEI, or the Standardized Precipitation Evapotranspiration Index, all the great words. And you can see that we're not just looking at what's been going on for the last 12 months, because we want to know that long-term aspect. So we're looking at those last 60 months. So what have the last 5 years been doing? And you can see that, especially in Arizona, the Southwest in particular, you're seeing that the last 60 months have been in that long-term deficit, not just lack of precipitation, but also hotter temperatures. And so if you want to zoom in and you look at the last 5 years in Arizona and kind of how that ranks. So you add everything up, you look at everything together. How does this compare to the other time frames? And you can see that we are experiencing the 6th hottest from September 2020 to August 2025. So the 6th hottest, and then the 7th driest. So it has been exceptionally hot, exceptionally dry within those last 5 years. Now, how's the monsoon going, right? So if you've been here for a longer period of time and experienced some of our monsoon events, you know that it's a hit or miss. It always is. Every summer is different. The monsoon, we start counting that precipitation June 15th. We stop counting that precipitation the end of September, September 30th. And then we can compare what's happened on previous monsoon seasons, kind of how we stand. Some monsoon seasons are very, very wet. Some monsoon seasons are very, very dry. It's not everywhere across the state either. You know that you can get a thunderstorm in your backyard and your friend down the street will be completely dry. It's the nature of how the storms operate in the summer during our monsoon season. They're convective in nature. Warm air rises, drops down, you get that precipitation. You get all of that precipitation in a short period of time. We count it. And you also don't get it continuously. So you're not going to get thunderstorms that are happening every week. You're not getting them every month. You're getting them when they come. And so you may have a wetter August, you may have a wetter September, and that's absolutely the nature of how that precipitation during our monsoon season operates. And so looking here, what we've been experiencing with monsoon 2024, we just experienced over this weekend a system that really was built by a low pressure system that came in off of the Pacific and kind of acted like those kind of storms that we can get in winter sometimes. So those cold front kinds of things. That's not what this was, but it felt like that because you're getting that precipitation all over the place and you're getting a lot of precipitation. And then we did see that kind of highlighting. So from Thursday, we did see that in kind of Gila County, getting a tremendous amount of precipitation in a short period of time. And then Friday and kind of coming into the Phoenix metropolitan area, central Arizona, Saturday and Sunday kind of tapering off a little bit. So the monsoon season that we just experienced, we're probably done with our precipitation now. So we have a couple more days, right, to count that precipitation. We're expecting it to be fairly dry. We're expecting the westerly winds to come in, so dry out kinds of conditions, those dry winds coming in. And so overall, it's more than likely going to end up for most of the state to have been a kind of dry monsoon season. Some of the locations, so you're seeing Yuma County kind of building up, and you're seeing that really brought in some moisture that was more of a system, a tropical system that came in and kind of hit Yuma. But we didn't see that regular activity kind of in the south, the southeast. Pima County is going to end up being below average. Phoenix, so if we zoom into the Phoenix weather station, they're going to end up being above average just based on what we experienced on Friday and Saturday. So that's the nature of the beast. So you can kind of see some of the previous monsoon seasons, kind of looking at that entire time frame. So for the most part, we've had a couple of dry monsoon seasons, and then we've had a couple of wet monsoon seasons. Before that, a couple of dry monsoon seasons. Doesn't go everywhere, doesn't hit every time, doesn't always be perfect. But sometimes we can have the winners and sometimes not so much. And that's kind of what we're experiencing here. The other thing that we kind of experience when we're dealing with having all of that precipitation in a short period of time, especially coming from a dry and a hotter kind of soil, paying attention to our soils becomes really important. Because when we're dealing with those dry soils, we get a lot of rain in a short period of time, you're going to have that flash flooding. And then once we get that moisture coming in, antecedent soil moisture kind of building, we get a lot of rain in a short period of time, it's going to do the same thing. It's going to run off. You're going to have that flash flooding. So it's important to understand that when we're looking at that summer precipitation, it's not really something that we're looking for our water supply, for our summer precipitation. We're looking more for getting that water and helping our soil, because if we have that wetter soil and here comes winter, when we get our snowpack and the snow starts to melt, the snow will go into our supply instead of going into the ground. So all of these things play a role. They operate together with our climate. This, I think, is of interest when we're looking at October to March. And what you're looking at here are ways to kind of keep track of that October to March precipitation for these individual counties. It's going across the state, and you can kind of see locations that have been above average for that October to March or below average. And then you can actually see the actual amount of precipitation that might have been received from that time frame for that county. So kind of getting a sense as to whether it's been dry, whether it's been wet. This might be of help to understand how we keep track of those numbers as well. So it's a county level kind of approach, looking at a time frame, but you can look at these things individual months, you can look at them over the 6 months that we're looking at here, but kind of going back and forth, kind of dealing with that same kind of thing, especially when we're looking at that winter precipitation. Not every winter is going to be wet, not every winter is going to be dry. What we expect to happen for this winter, right? So the expectation, we're looking at going into a La Nina. Perhaps there's a higher potential, so over 50% chance. I think there's a 70% chance right now if we're looking at the likelihood of having a La Nina for the state. What that means when we're dealing with a La Nina event is that the storms tend to stay north of the state. And that means when we have a La Nina winter, it tends to be dry. Not every time, not every event, but it statistically tends to be drier when we have a La Nina event. We'll have to see as we get closer what we might expect. But essentially, hopefully that was helpful, a little bit of information about how we keep track of all of these numbers and temperatures and how they might be of assistance to you and your team. And I'm happy to ask any questions. Thank you.
Thank you, Dr. Saffell. One question I have is, what do you think the future of Arizona is, like in regards to droughts, is this just a cyclical pattern of every 5 years? I mean, you said something along the lines of, over the last 5 years, it's the sixth hottest or the
That's right.
fifth driest or somewhere around that. So do we expect to like break through this where we're experiencing cooler temperatures and more precipitation or what?
Right, that's a great question. And so looking at these kinds of things, so I was born and raised here, and I remember the 70s and the 80s. And if anybody moved here into the state in the 80s, they might have remembered a very wet monsoon season, a very wet decade in the 80s and into the 90s as well. January 1993 was the wettest January on record for the state. And then all of a sudden, not so much. We moved into a drought. And so I mark the start of our long-term drought as 1994. And this long-term drought, when we're looking at the precipitation, so we have 130 years of record, those last 30 years, how do those compare? We're about, well, let me just back up. For the state, the long-term average of precipitation for the state is about 12 inches annually, which doesn't seem like a lot, but that's what we do with our state. Now that we've been in a drought for the last 30 plus years, our average for that time frame, we're losing an inch, which is significant. When we only have 12, now we're down to about 11. So looking at that, long-term drought is part of the ecosystem of Arizona. We've been in long-term drought before. Are we going to be coming out of this drought? That's what we don't know. Drought is a very hard thing to understand. We had our first time for the state to advise that we were in a drought in 1999, and you can see I mark it as starting in 94. So it's not something that we can see that we're going to be immediately coming out of, or that we're immediately in, as I mentioned. So it's a tough thing. It's going to take, are we going to come out of this drought? That's what everyone wants to know, right? It's going to probably take a couple of years of having wet monsoon, wet winter, wet monsoon, wet winter. Do that for a couple of years. And at that time, we might be able to say, okay, it looks like we were probably coming out of this longer term drought. Is this part of what we normally experience? Historically, some of the historical records using dendrochronology show that they last about this long. Yeah. So
30 years.
30 plus years, 50 years, yeah, absolutely. So that's where we're standing right now. So keeping track of all of those things, I think, becomes important.
So looking at what you're talking about, and you started in 94 is where you started.
That's when I mark, our drought.
And I mean, looking at those drought, I mean, there's very few years where you have above average multiple years or below average multiple years.
Yeah, it's about a 2/3 to 1/3. So we've had about a third where we've had wetter season, whatever it might happen to be, about 2/3 below average.
So those are just spikes within the year.
That's correct, or spikes within that time frame of the water
so
year.
That really drives what kind of our bird populations, those winter precipitation, summer precipitations for the different species. So, but is there modeling that's done based on data? I saw something out of Texas years ago.
Not at our office that we're doing that. We're keeping track of numbers just like what you're seeing here. But there are folks that do various different areas of research that you might.
Modeling in general.
Yeah, and that's not what our office does, though. Yeah.
So in that time frame, or since the drought started in '94, it seems like we rarely get both a wet summer and a wet winter, and it's either one or the other, or it's neither, but it's never both.
It can be, right? It can be, but it's more than likely that we're going back and forth. And so I do keep track of that as well. So I'll keep track of what we've been experiencing for winter, what we've been experiencing for summer, and has it been above average, has it been below average? And you're right, for the last 10 years or so, easily, you're going to see that back and forth, back and forth. But you certainly can have 2 wet winters in a row, you can have 2 wet summers in a row, but having everything happen continuously, that hasn't happened in a while.
But is there something about the forces that bring us a wet summer versus a wet winter that counteract one another, that's not gonna happen? Or is it possible that
Yeah.
we'll someday see?
Yeah, the precipitation that we experience in the Southwest, we're not seeing any big changes globally controlling what may cause these things to happen. And so we're not seeing a big expectation that we could continuously dry out and stay in this drought. We're seeing kind of the normal aspects of precipitation. Hotter temperatures, yes, we're seeing those hotter temperatures across the Southwest. We're seeing it across the state. We're seeing an increase in temperature. But the precipitation is doing kind of what it's been doing, where sometimes we have the wet winter, sometimes we have the wet summer. Yeah, sometimes we're in drought, sometimes we're not.
But do the forces that predict a wet summer, are they in opposition to what they would be to predict a wet winter? I mean,
so the wet summer is a trick. You know, it's hard to do. When I say it's a trick, it's a very hard thing to expect earlier. It's a very hard forecast. So if we're looking at the forecast that was expected for this monsoon season, so we start looking March, April, kind of seeing how things might come together. And it was expected to be a wet monsoon season. And then we ended up having a tropical system early June, and then it dried out, and then it dried out, and then it dried out. To the point that if we hadn't had this event that happened here recently, it would have been exceptionally dry for the monsoon season. So we never know exactly how it's going to come in and play. What we deal with in the early part of the monsoon season is we're looking for those convective thunderstorms coming in. So we need that moisture coming in from Mexico. We need to have the setup of the high pressure, so the monsoon high needs to build up kind of in the Four Corners region. So if it's there and it's of the right size and shape, it's going to pull moisture in from the south. Now, if that's a little off, it's going to pull moisture into New Mexico on the east, like that's what we saw. So having that set up and where it's supposed to be is never a certainty. We know what we want. We always want to watch for it, but it's never a certainty. And then what we're experiencing usually in August and September, we start to get the tropical cyclone systems coming in, and that's never a certainty as well. But sometimes the remnants, those tropical cyclones don't hit Arizona, we get the remnants, we get that moisture. So a lot of times it can go into California. Hillary did recently. And you can get a lot of precipitation in a short period of time where it's not expected, like in California, and you have flooding, flash flooding events. Or it stays over kind of in the Yuma area like it did. So that's the trick, is like, where are things going to go? And so watching the atmosphere continuously is what we do, because the atmosphere plays that role into where things go. Yeah.
So would you say that it's long-term predictions of winter precipitation are more likely to be accurate than summer precipitation, or is it?
The winter precipitation that we look at has a little bit more of a way to tell. It has more of a tell, which is the El Nino, La Nina kind of situation. But even then, those are just statistical relationships. We had 3 La Ninas in a row, which I mentioned was one of our drier statistically times. But we had 21, 22, those were 2 dry La Nina winters, and then 2023, which came in, was exceptionally wet. That was a La Nina. So it's not always 100%. It's a statistical relationship. Yeah.
If you have a monsoon that's very wet, like a really wet monsoon, does that lower the probability that the winter will be wet? Is there any relationship there? So say we have an unbelievable monsoon, does that increase the probability of a wet winter or decrease?
It's the other way, where when we're looking at a wet winter, that tends to delay having all of those things that I described, building up that ridge of high pressure. That is can delay, and that's what we saw happening recently, where we're like, okay, it's kind of, where are we expecting things to be? A wet winter, keeping us dry. That's kind of what we kind of see sometimes. So what we were expecting for it to be a wet winter, for a wet summer this year is because it was so dry last year. So we kind of thought of that, like maybe because it had been a dry winter, things were dried out, maybe we're going to get that ridge of high pressure setting up early. That's kind of how we look at these kinds of things. But it's a better tell, it's a better relationship for the winter to the summer than the summer to a winter.
Okay, so if it was a really wet winter, then that means there is some statistical probability that it's going to be a drier
That
summer.
it delays the onset of the monsoon. But not always, right? We know these things.
Yeah.
I think that's why we all enjoy watching it so much,
Yeah.
right? What else can I do for you
we
folks?
enjoy watching it because we're anticipating how it's going to equate in quail numbers subsequent fall. But you pointed out how difficult it is to predict what the weather's going. Predicting what the quail numbers, which are going to respond to that weather, is even more difficult.
I bet. How quickly do they respond to that precipitation? So a wetter
within
winter.
A year, they will respond.
They'll respond.
But yeah, if you have a summer like we had here, where you just have a wet June and then a dry, you need a summer that is consistently wet throughout those 3 months for the vegetation to respond, and they're responding to that vegetation because it's providing both food and cover, and so it equates to increased nest success and survival of young, and so you have to have it all come together, and so it's.
No, I would agree. But I would also encourage you, since you're also interested in what's going on with the vegetation, is understanding what's going on with the temperatures, because those hotter temperatures and those drier conditions. So if we have fewer thunderstorms, it's going to be hotter and drier. We know this, right? So that's what you're seeing. And that's what you're seeing some months through the monsoon season, not every time, but absolutely.
Yeah, so I often get questions about, it finally rained in September, is this going to equate to more birds? And probably not. It had been raining up until this point, sure.
Yeah.
But,
One of the things I've heard from other quail hunters is that it was the 90s were some of the best years of hunting, and the various species, the desert birds respond to the winter rains, the Mearns quail responds to the monsoon rains. And so, was there successive years of wet winter, wet summers, wet winter, wet summer happening during that era?
That was prior to this current drought. And so you're looking at the late 70s, the 80s, into the early part of the 90s, fairly good. Fairly kind of what would be expected with having that annual precipitation of 12 inches or so. Yeah, that long-term kind of thing. Yep.
So we're only down 1 inch though, and it's a drought?
Well, that's statewide. That is what percent when you're looking at 1 inch out of 12 inches possible? That's significant. So we don't get a significant amount of precipitation. You take a little bit of away. Yeah, and then again, it's not everywhere across the state. And that's why we look at that short-term drought every week. Who's getting the precipitation, who isn't? That's why we look at that long-term drought. Yeah.
What are some of the wetter areas of the state? You could tell us that for winter and monsoon.
It's every year's different. And so I think one of the things that you can do, though, is kind of, let's see if we'll go the other way, looking at the short-term drought and seeing where those persistent kinds of those dark reds and those dark oranges, that's where you can see things that haven't really cleaned itself out, even if you're getting a good amount of precipitation. So looking at Cochise County and looking at Greenland County, right in through there. I was just down in Rodeo, New Mexico, last weekend, and we got a good amount of precipitation, but they're still in that long-term drought. And so it's going to take a little bit more than having a good event to kind of clear that out. So that'll help you see it.
The dark red is the severe drought?
The exceptional, yeah. So you're looking at those colors there. So the dark red is the worst part of it. Yeah.
Okay.
I noticed you use a lot of the data came came out of that Cal weather for monsoonal rain? What is out of
The-
the University of Arizona?
Climas, yeah.
Is that what that's called?
Yeah, so let's see if we can get that. This is there,
That
right in
one
through
there.
there. Yeah, so you can absolutely look at my website. I have links to everything that you're seeing here. You can see everything. All of these data are available to everyone. And so I keep everything on the website. It's me putting the information that I actually use, putting on the website, so you can get all of that data.
I follow this very closely.
Yeah, yeah.
But is there a website that shows this same type of mapping
Yes.
with winter precipitation?
Yes. So you can, yeah, I've got links to all of that that might help you to find everything, because there's a lot of things going on out there for sure. But the National Weather Service Tucson office has a monsoon page that you can get that information from as well. And the monsoon page for the National Weather Service kind of gives you some of the various different locations. So you'll see Phoenix and Tucson and Flagstaff, and I think they have Wilcox and a bunch of other of those weather stations. Not everywhere. Gives you a good sense. It's for the monsoon though.
But not for the winter? It doesn't
Not
have-
through the winter,
Okay.
no. But yeah,
With Phoenix expanding as rapidly as it has over the last 30 years, does that also play in part with the drought?
you're talking about the urban heat island for
Yeah.
sure. And what we're seeing happening with, and I don't have a map of this, but I can certainly show you those data, that if you look at the changes in temperature, even statewide, the daytime temperature, maximum temperatures, those have been increasing. So statewide temperatures have increased by about 2 degrees for the last 120 years. The nighttime temperatures over the last 30, 40 years, and we'll just zoom into Phoenix, those temperatures, those nighttime temperatures, so those are minimum temperatures, how much are we cooling off at night, are heating up twice as fast as the daytime temperatures. And it's not just looking at the Phoenix weather station, it's happening everywhere, because you're looking at the urbanization and those, you know, the pavement and the parking lot that holds on to the sunlight, stores it and releases it slowly at night, so it makes your nighttime temperatures hotter. Yeah.
Does that play also a part in the precipitation around the Phoenix area and how
We're-
the storms roll through?
We're not seeing that. I know, right? That would be great to know. But these convective thunderstorms in the summer are usually big and bad, and they'll take over what they're experiencing. And then if we can cool it off, they'll also cool it off. Those thunderstorms help us cool off.
Yeah.
So yeah, it's a whole process, isn't it?
Yeah.
It's fun to watch.
So, given the localized nature of the monsoon storms, these maps must be the result of some modeling, because we don't have weather stations at the level that these are indicating.
Right. There are a lot of different groups that will help us kind of fill in the gaps when we're looking at that lack of rain gauge in that location. Right. You have to kind of interpolate is the term that's called, where you're kind of taking these observations here, 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 and kind of saying, well, what would it be like in between? Right. That's correct. That's what you're saying.
And so do those take into other, like environmental or topography?
It would,
other-
yeah, and it would, yeah.
Okay.
But it would be based on that interpolation of the actual observations and trying to create a grid of it, of sorts. Yeah, yeah. It's a tough thing, right? Precipitation is one of the harder things to measure.
2 questions.
Sure.
One being, does your group from ASU and your role as a climatologist, and does your department or organization that you're associated with, do they partner to provide research and advisory roles to other organizations, kind of like you're doing here today? And how common or not common is that?
Right. So as the state climatologist, I serve the state. and that serves the various different state agencies. So I work closely with the Department of Water Resources doing those kinds of things. That's where we meet every 3 months to evaluate what kind of drought level we're at, every 6 months to evaluate with other folks around the state. Yeah, those kinds of things. So it's a service to the state more than anything that we do.
Wow.
Yeah.
Okay. And then I'm curious as to has there been any conversations for your role to work with or bring advice to, like, Arizona Game and Fish Commission, just because that's a state agency?
I will talk to any state agency that wants to have information, and I do. I talk to a lot of different state agencies
Okay.
to advise, to provide information, to give stats, those kinds of things. Yep, that's we all try and build so that we can help and serve.
Yeah.
Yeah.
Yeah, that's fantastic. And then the second question is, how, you probably understand Arizona weather, like, very clearly, but how unique do you think Arizona weather, and specifically monsoon, winter rain patterns, are in comparison to other states and weather systems?
Yeah, no, I mean, so New Mexico
Okay.
and Arizona are kind of paired. And then you can see that Utah and Colorado, so the Four Corners states,
Yeah.
they'll kind of get remnants as they come in. You can see Nevada a little bit, but Nevada and California have a little bit of a different operation that they look at. So it's more Arizona, New Mexico, we kind of buddy up together, but New Mexico gets so much more precipitation than we do.
Yeah.
And so it's kind of just looking at how all of these things operate. For example, like New Mexico may not have that same kind of impact for atmospheric rivers that we can experience here, that are a big part of getting precipitation in winter in California. So we can get some remnants of that. New Mexico kind of tapers out. So it's just really, everything is unique. Understanding what's happening in the state, I think, is important. Understanding how it operates, I think, is important. And that's what I try and bring. It's that perspective. It's more than just one weather station, one number that you might happen to see. What are we seeing with that trend? What are the extremes? What are the trends? What do we see? Yeah, that helps. All right, you're all welcome to sign up for a class in Introduction to Physical Geography where I talk about this stuff all the time. Right? No, I love this stuff. I want people to understand what's going on around them. I want people to, the deadly event that we saw this weekend, I want people to understand what's going on around them so they can keep themselves safe and the people around them safe from these kinds of events. It's the way it operates when we're talking about that heavy precipitation, the extreme winds, all of those things.
So can you speak to that just for a moment? The massive downpour of rain that we had in this last few days, the monsoon. Mm-hmm. Was it hardest hit, like, Globe area, or I saw some pieces of that?
Yeah, I did put that up on social media, a picture of where you can see, and it was the central Arizona. You did get a lot of precipitation, upwards of 3 inches in some areas. And when you're getting that much precipitation in just one day, 24 hours, you're dealing with some significant flooding events. And, it's horrible, it's sad, and it happens as part of our convective nature of what we have. So we want people, you can't stop it, we want people to be more aware of how to kind of keep themselves safe and understand what they're dealing with. That's what I try. Yeah. All right. Thank you so much. I appreciate your time.
Thank you.
Thank you.
All right.